Today, I'm just going to give a very brief overview of solar photovoltaic technology, what it is, why we can utilize this technology, and how we can fund it, be that by a self-funded capital outlay or through different mechanisms and funding streams that are available out there. Before I jump into the what, the why, the how, I always like to start on this illustration of a standard grid-tied photovoltaic system. So we're not going to get into the mechanics of photons and electrons and that type of thing, but how solar PV systems work, I'm sure everyone is well aware. They convert sunlight or daylight into electricity, and that is through the photovoltaic effect. So you may hear me referring to PV or photovoltaic throughout this presentation, and that is essentially just talking about solar. And what happens, as you can see, the modules here on the roof, they harness the sunlight. A photovoltaic effect occurs and a DC current is created. A DC current is then fed through some DC cabling. Here we have an isolation switch. And then the clever bit, or the brains of the system, is this inverter. And what that does, it converts or inverts DC current into AC so that it can be consumed, or the power, solar generated power, can be consumed within a building. And then it's fed into a distribution board or the fuse box. So that power has been generated from the roof, from the panels, can be consumed on site. And with it being grid tied, any surplus electricity that is generated and is not consumed on site by a homeowner, a building owner, or a school building, then that surplus electricity is sent back to the grid, and you will receive a small tariff for doing that from your energy provider. So up until last year, there was this thing called the Feedin Tariff. That was the main driver of solar PV. However, has been abolished now as of March last year. So gone are the days where you are rewarded just for generating. You used to be rewarded financially just for generating solar power, and that was irrespective of whether you consumed it or whether you sent it back to the grid. And then, of course, if you consumed it, you were saving on your bills. And if you sent it back to the grid, you received a tariff for that as well. So up until last year, it was great, in terms of there was 3 ways to get paid. However, due to electricity prices and other drivers, which we're going to touch on now, solar PV has never been more popular, even without that feed-in tariff, which was, designed to help industry get off the ground in terms of solar PV. Now we have things like, UK's ambitious target of becoming net zero by 2050. Boris Johnson has, there's a quote on screen which says, "As a country, as a society, as a planet, and as a species, we must now act." And that was, back in October last year. And this is, of course, to do with climate change and the adverse effect that our reliance and overusage of fossil fuels is having on the ecosystem, what it's doing to the planet. So there is a climate emergency. It has, it's a well-known fact now, and it is in the public conscious. And because of that, we are signing up to these ambitious targets to become net zero by 2050. Boris Johnson again, although I do take a lot of what he says with a pinch of salt, but he does seem committed, and as a country, we are committed to reducing our carbon output by 80% of what the levels were in 1990, and that's by the year 2030. So we're going to, in the next 10 years, drastically reduce our carbon output by 80% compared to what we were, producing in 1990, the decade of. So, it's a mammoth task, and in order to achieve that, there's going to be lots of different energy efficiency technologies and renewable energy technologies at play. However, solar and solar PV will be one of the primary, if not the predominant technology in order to help us achieve these carbon reduction policies that are being set. Schools should be looking to provide climate leadership, and of course, as well as the added benefit of pushing that green agenda that you will no doubt be tasked with, you've got the added benefit of the financial gain and energy reduction. through the implementation of solar PV. So in terms of schools and academies, like everyone else, homeowners, business owners, we've seen a huge increase in the cost of electricity over the last couple of decades. And I believe there's been about a circa 25% uplift in price in the last 3 to 5 years, which is for a large secondary school equates to around about £18,000. It's a lot of money. There's pressure to save money and secure energy bills, and often, maybe not the capital there to do that. So, as I say, this presentation will hopefully give you some pointers and ideas of opportunities to be able to implement this technology. As a business case, what you get from the sunshine, if you like, and the solar panels and the solar generated electricity is free. Of course, once you've repaid the investment or the initial outlay and capital expenditure of the installation of the system, which is circa 7 years, depending on the size of the school and the size of the solar panel system we can fit on the roof. But yeah, typically it's a 7-year payback. And then for the remaining life cycle of the solar PV system, which be another 20 years approximately, you're going to get free electricity from the solar panels on your roof. And as I said before, it's the system is grid tied, so any surplus electricity does make its way back to the grid. And depending on who your energy provider is, you'll receive between 1 to 6 pence per unit for each unit that is sent back to the grid. Of course, by having your own energy source from the solar panels and consuming that free power, you're then using less from your energy provider and you're pulling less from the grid, which of course in turn will have a substantial effect on your energy spend per year in a positive way. Now, when installing solar PV or designing any type of system or any type of roof, then there are some things to consider, but I'm not going to bore you with every single thing what we need to factor in to a PV design. But what I would say is these top 3 are really key. The waterproofing structure. So unfortunately, as a flat roof manufacturer, the amount of times we get called out to a roof which is very old and aged and the membrane is close to failing or already has failed, and a solar company has gone along and put a heavy weighted PV system on top of this old and fragile flat roof, and of course the roof started leaking. Bauder, would first and foremost do a roof survey to establish, the condition of the roof and provide some recommendation as to the requirements to bring that roof back up to, building standards. So the waterproofing structure is very key. If you've got an old roof, please consider refurbishing and replacing that roof before going down the route of solar PV. Otherwise, I dare say you will have to remove and reinstate and eat into a big chunk of your financial returns from the solar PV system. So existing roof considerations and warranties is something to bear in mind as well. And then, of course, how are you going to install the solar system? Be that on one of your pitch roofs, in a big field maybe that you have, if you were looking at ground mount, or if you were looking at flat roof, how are you going to safely install that solar PV system? And there's a few different ways to do that. Either on a flat roof, you can either ballast, where you're weighing the system down with concrete blocks ordinarily, or sand or water has been used in the past, or whether you're going to mechanically fix into the waterproofing structure and potentially causing defects. Now, Bauder do have a unique system, which we'll shamelessly plug now. And this is only compatible as a caveat with our flat roof membranes. But we've come up with a unique way to install solar PV onto a flat roof with a really low risk solution. And how we do that is we weld the top surface to our bituminous or single ply membranes. And we do that with a prefabricated membrane sleeve. And what happens is sleeve is bonded either bitumen to bitumen or single ply to single ply from our roofing contractor. And that gives a really solid grid and structure for a solar PV mounting system to be installed. But the key thing, and you know, the main benefit, if you like, of this method of installing to the roof is it's a completely zero ballast solution. So it's very, very lightweight in comparison to other systems. And we're not going to affect the integrity of the structure in the building, or even the integrity, you know, compromise the waterproofing structure as well, by negating completely the need for any ballast. And as well as that, we take away the need for any penetration. So as a solution, it's non-penetrative and completely zero ballast, meaning it will never exceed 12.5 kg per meter square in weight. It's very quick to install. I guess one of the main benefits is it's a single point liability for both the roof and the PV mounting system, because Bauder manufacture both of those applications. And here's a nice video just to showcase how it is fitted onto the roof. So as you can see here, the membrane sleeves are welded down onto the base plates, which will be provided by a dimension drawing across the roof. And then from here, a bracket sits on and is clipped into place with a bayonet cap. So no tools whatsoever are required. Again, the panels are installed via a spring-loaded mechanism at an aerodynamic angle of 12 degrees. And we leave a nice 385mm gap in between rows. And because we're angling the system at a low angle, due to the way we fix to the roof, it needs to be aerodynamic. But as well as that, it means we can maximise entirely the roof space that we are working with by fitting more rows and more panels on the roof. So just as a recap on that system, it is completely non-penetrating, completely zero ballast, and there's a one-stop shop for warranty for both roof and PV system. Last few slides, we're just going to look at the different ways to fund solar PV. I always advise clients, if they have the capital to invest in solar PV, that is by far and away the most effective and provides the best return on investments. So outright purchase is the best way. There are other things called power purchase agreements, which is a completely zero capex solution, and we'll touch on those shortly. And then you have different funding streams or mechanisms or vehicles, if you like, via Salix is a really good body, as I'm sure people have heard of. And many people will be aware at the moment there is a real push energy efficiency projects via the public sector decarbonisation scheme, or PSDS as the acronym, or CEF. It is a predecessor to PSDS, and that was the Salix Energy Efficiency Fund. So yeah, there's different ways through Salix we can apply for funding to implement these energy efficient technologies, not just solar, you know, lighting, LED lighting, heat pumps, and other technologies are available through this process. And then as well as that, you've got things like the Department for Education procurement scheme, which is a framework that has been in the pipeline for the past year or two, hasn't yet come to fruition, but I believe it is soon to be in inception, and again will provide an opportunity for education sector to install and implement energy efficiency technologies. But as I mentioned, the two we're going to touch on as case studies are the self-funded or outright purchase option and a community power purchase agreement. So as a case study, Tony Redfale School is a school in Wales where we installed a large 85 kilowatt peak solar PV system at a big secondary school. And one of the key things when designing these systems is making sure that the solar generated power is going to be as close to 100% self-consumption as possible. And that is because by consuming all the generated power, that school will save 14.5 pence per unit than what they would ordinarily pay for that electricity of their energy provider. And by doing that, what that then provided was a saving of £10,500 in year one alone. and an estimated saving of over 25 years of £373,000. As I say, that system will have paid for itself, as you can see on the graph here, in around about 7 years. That's the break-even point. And then from there, the estimated savings were just shy of £375,000. The pros and cons of capital purchase: it does provide the best return on investment. The school will own the system, so no complex contracts. However, sometimes finding the capital can be an issue. Of course, it is a CapEx solution, so that can be a problem. And the school would be responsible for monitoring and maintaining the upkeep and the performance of the system if they wanted to maximise those return on investments. If CapEx is a problem, or a zero CapEx solution is preferred, then there are these power purchase agreements out there, which essentially is a contract between two parties. One which generates electricity, the seller, or in this case, the funder, and one which is looking to purchase the electricity, the buyer, which would be the school. So no chance of the school being out of pocket because it's completely zero CapEx, should I say. It provides energy savings from day one and year one with a very simple contract. So just as an overview, how it would work is a funder like Energy for All, this school's energy co-op, who's a partner we work with, they can provide a community power purchase agreement. They are a non-profit organisation, and they will raise, through their shares and through their member shares, they will raise the capital for the installation of a solar PV at your school. Then what will happen is they will operate and maintain that system for 25 years. And how it works for the school is the school will enter a power purchase agreement to buy back all the solar generated power from Energy for All, or the school's energy co-op, showing, so that the school buys back all the power from school's energy co-op at an agreed rate. In this case, it was 9 to 11 pence per unit. And if the school is paying 15 pence per unit for electricity from the energy provider, then this immediately provides a saving on energy spend. So it's a great way to install solar, not have the headache of managing the system for 25 years because it is operated and maintained by the funder. And yeah, as I say, it's a non-profit organisation, so it is given, the PV system is given to the school after 25 years, fully maintained, and you will probably receive a circa 10-year plus additional life of the solar PV system and all the additional energy savings that will bring. Recently, in the last couple of years, I've worked with an academy trust in the Midlands called Academy Transformation Trust, and through the school's energy co-op, we installed solar across 16 schools, and this totaled a kilowatt peak of 685. So a lot of solar was installed across 16 sites. The trust, as I say, didn't spend a penny. They just entered power purchase agreements for each school to buy back reduced electricity than what they were already buying off the grid. And what that meant was they saved in year one £24,500 on their energy spend. And with a 20-year projected saving of over £1 million. And as I say, again, that was without any capital outlay whatsoever. So that's clean, green energy as they re-roof their buildings and took advantage of the opportunity whilst re-roofing and whilst, to utilise this big open space without any capital expenditure, and help boost and meet some of the building's energy profile with a solar PV system at the same time as refurbishing their roof. And there was no maintenance responsibility to the trust whatsoever. Out of the providers, we work with another organisation called Solar for Schools, who, same as Schools Energy Co-op, can provide this power purchase agreement for the education sector. Or we can advise and point you in the direction of Salix or the DFE procurement framework when that comes into play. But just to conclude, solar PV, as I say, is a really low risk option for reducing both energy costs and carbon footprint of a school site. It ensures minimal impact on the building structure, particularly with this Bauder solar solution, which is very lightweight, and it has combined roof warranties as well, which is vital. There's numerous funding options available, as we've just touched upon, and community energy power purchase agreements, or PPAs, are a great option for sites and schools or academies who do not want to spend money on investing in solar.